Let's take a look at the PIV of a half-wave rectifier when we add a capacitor filter. Now, PIV is your peak inverse voltage, sometimes written as PRV, which is peak reverse voltage, but it's a voltage across the diode in reverse bias. And in formulas, you'll have the PIV as written as ESM, which is your maximum voltage across the diode. But in the data sheets, you'll see it as VRRM, which is a maximum repetitive reverse peak voltage. Okay. So if we just take a diode here, I've got a transformer here. I'm just putting 12 volts in here. It's got to be 17 volt peak on there. And we put it through a diode. So we make a little half wave rectifier here. Now, I have my ground probe here on the oscilloscope, and I have channel 2 over here. And on channel 2, you're going to get 2 of these pulses up above the zero line here, okay? There's going to be a half wave rectification, but the peak on that is going to be 17 volts peak, okay? Our RMS value is 12, but our peak is going to be 17 volts. Now, channel 1 is down here, and basically that's just right across the source here. So that's going to be a full sine wave with a peak of 17 volts. So just going to match up there, okay? Now, the capacitor was open. We close the switch here, close in the capacitor here, and we take a look at channel 2 here. Now, channel 2 is way up here. Here's channel 1 down here. This is the source. And channel 2 has been risen up above the zero line here. Now, it's so what happens here is when this transitions to this is plus and this is minus here, then the capacitor can discharge back in through the diode here, and that bias voltage from the capacitor adds an offset, so it pushes the sine wave up above the 0 point here. Okay, now the peak coming in is about 17 volts, but this one here is going to be about double minus the drop across the diode there, so say 32 volts or something. So we're going to put it on the scope, and we're going to actually measure this and see how much peak we have. Now, 32 volts, you know, on a diode, that's not too bad, but I'm using 12 volts here just because it's safe. But if you actually were going to put 120 volts into here, then instead of having 32 volts across the diode, you'd have 320 volts across the diode. So you have to pick your diode according to how much peak voltage you have. So if you're adding that capacitor, you're going to have to double your peak voltage. Okay, so we'll go over and take a look at the oscilloscope and see what the waveforms look like on the scope. Here we are at the oscilloscope. The yellow trace is our source, and the purple is our half wave rectification. You can see that they match up, the same peak on both of them. And then we add the capacitor to it. Switch that over. There we go. And that adds a bias to it, and it brings that the voltage across the diode up above the zero line, and it says the peak of that one is 32 volts now, and the other one is at 16 volts. So yeah, so we're basically doubling the voltage across that diode. So that's all there is to it. Thank you.